Okay, so this is a brief introduction to hazard identification and control. In the following weeks, I will talk about some of the hazards in detail, which relates to your characters, working at height, industrial hygiene, mechanical hazards, and also biomechanical hazards. Okay, so in OSH, one of the most important term, in addition to accident or disaster, is a hazard. So hazard is a very important term for anyone who is involved in OSH, and in general to anyone who works at risk, who are at risk at work, to understand what is a hazard, because that is a very important term to understand. If it's in Malay, usually we call it as danger or bahaya. Bahaya ni tak boleh buat ni. Janganlah buat ni, bahaya lah, tikang. Those are the the daily slangs that people use lah, that refers to hazard. Others might call it as danger, but in OSH we call it as a hazard. And hazard is a term that is already accepted in the Malay dictionary lah, by the Dewan Bahasa and Pustaka as an acceptable term. So if it's in English, it's called a hazard. If it's in Malay, it is also called as a hazard with the same spelling. You can find a lot of definition out there about hazard. Some of the most famous or popular, or is used by a lot of people, refers to hazard as something that can cause harm. Something that can cause harm. So that is the general definition of a hazard. However, for those who are studying OSH, it would be preferable that you refer to a more detailed definition rather than that. And one of the definition of the hazard that I would like to propose is the one that I made. Okay, this is a definition that I made myself. Okay, what is a hazard? A hazard is an agent or a source, or a combination of agent or a source in the form of an object or an organism or a chemical or a substance, a situation, a condition, or an energy that can harm, damage, or negatively affect either immediately or gradually, sama ada dengan segera, serta-merta, ataupun mengambil sedikit masa, anything that we want to protect. A hazard can either be visible or hidden. So if you use the popular definition, something that can cause harm, it's rather vague. Something, what is something? There's a lot of things that can be considered as something. So it is up to the people who is looking at the hazard to define what it is, something, and then can cause harm. Harm is also a very general word. Okay, so in my definition, it is extended, not just harm to people, but also damage to things or assets, or negatively affect. Might be using other words than harm or damage. It might be injury or poisoning, okay, or destroying, whatever it is. So it is an extended and more in-depth definition of what is a hazard. So this is something that we need to identify, because a good safety management is basically where organization is able to identify what would be their hazards that exist in their workplace. And then the next question would come up is, how do we identify a hazard? Okay. Now, to an untrained eyes, to somebody who have never learned about hazard, so this is something that can be carried on from the things that you have learned from your home, something that has been shared by your parents, something that has been shared by your community, something that has been shared by the school, where you learn. That is where the source of your learning about what is dangerous or what is not. But if you are not trained uh, about hazards in detail, it's kind of difficult for somebody to identify hazard, especially those that is hidden, that is you cannot see easily with your own eyes. That is maybe within a process, like electricity, something that you cannot see, or a substance within a pipeline, or underground, something that you cannot see. So it is very important for everybody to be trained to recognize, or at least have some fundamentals or underpinning knowledge of what some of the common or popular hazards are. So how do we identify hazard? Okay. Number one would be by observing. This is something that is a popular method. For your quest 3, this is might be the only way for you to do it. It's by observing, by just walking around the workplace and looking up and down, left and right, looking front and back, and trying to find things that that you consider as a hazard, or can be dangerous, and that can harm or damage or negatively affect. So observing has a different style, and one of the most formal style would be what we call as workplace inspection. Workplace inspection is basically a formal plan process. So you plan to go to a place, you identify a place, and then you identify the date to go to that place, and you ask for permission to visit. And then when you go there, you will use a certain checklist. Sometimes a lot of people use checklists. Okay, and then you go through each area of the workplace systematically to cover all of the area, and using your checklist to identify what are the hazards would be. So that is the formal way of doing that, by a formal workplace inspection process. But we can always do the informal ways, which is just walking around. If you are at your home, you can just walk around, from your dining hall to your living hall, and then go to the rooms and to the toilets and all the places in your house, and trying to look for hazards that exist. So that is observing. So when you observe, you need to have a critical ability to to look for something that is maybe not easily seen by other people. We need to say you need to have a keen eye. So itu yang saya panggil lah keen eye, mata yang tajam, a keen eye. So that is something that you can train over time. So from time to time, if you do it regularly, then you can sharpen the skills for identifying things that is considered as a hazard. Or either way, you can also analyze a job. What we call as job hazard analysis. And job hazard analysis requires you to understand the step-by-step approach of a job. So usually a job should not be too long. you have to separate the jobs into a smaller portion, and that smaller portion usually consists of 5 to 7 steps. Don't go overboard by identifying a very complex job that requires like 50 steps. So that is gonna be difficult. So the job that you're gonna analyze is usually a simple job that consists of 5 to 7 steps. And then, well, for every steps, then you have to look at what are the hazards that can exist from each of the steps. Try to identify what can be done to control the hazard. There is a YouTube video that I put in here that you can watch how people conduct a job hazard analysis. There are also other terms used, that is JSA, job safety analysis. So if you see or read anywhere JSA, JHA, job safety analysis, or job hazard analysis, they are both the same thing. So you also need to be trained on how to do a job hazard analysis. There are a couple of documents required. You cannot just watch and write. It is a formal process also. Another way is to check the literature. So there are common jobs or occupation or process that is well known, already been researched by a lot of people from different industry, and they write about it in a document. Sometimes we call it guidelines, sometimes we call it technical document, sometimes we call it regulation that that writes about the hazards of a certain process, job process, because that job process is already considered having a lot of hazards, and the process is something that is done in a routine way. So to make it easy for everyone that is doing a similar job, so they can just read about it in a document. So this document usually have different labels. Some call it regulation, guidelines, technical standards, codes of practice, usually by the authoritative bodies lah, mana jabatan yang berkuasa lah. And sometimes it is a document that is written by the organization, the company. Usually when you buy things, for example, you buy a tool from the hardware store, for example, electric drill, for example. So together in the box, you can always find a operator manual, a leaflet, a document that tells the user about how to use it, what is the technical specification, and within that operating manual will also include the safety aspect lah. So in the manual also includes what are the hazards when you use the power drill, for example, and what are the things that you should be cautious of, and what are the things that you have to do in order to operate the power drill safely. So you don't actually have to operate the power drill and trial and error and do this and do that to identify the hazard. It's already been identified by the manufacturer. So you just open the leaflet and read about it. But most of the time when people buy products, they usually throw away the box together with the with the document lah. They don't even read it. So they just take it out of the box, plug it in, and just use. So for novice user, for those who just first time using a certain dangerous tool, it is very much recommended to at least have a read to identify what are some of the things that can be dangerous when you are using the things that you just bought. Yeah, this is something that I've mentioned before this. Check manufacturer or supplier information, especially when you buy it from other people, supplier. So by law, they should provide you with some kind of reference about what are the dangers of using the product that they are selling to you. So if you find that a product comes, when you buy a product and there is no indication, there is no reference, either in a leaflet or printed on the box, then that would be an issue lah, because the product might be dangerous and was not tested properly or safely, was not recognized by certain organization. So please be careful when you buy the product that has no information about it, especially on the dangers of using it. You can also refer to past accident data. This is especially useful when the organization or company has, good records of what has happened before, the accident that has happened in the company or in the organization, and it is publicly available, for example, so you can, just look at it. What are the things that have happened in the past 5 years or 10 years? There must be a pattern or a certain hazard that is so common within that organization. But for a company who has not recorded in the proper way, collecting all the data, the information about the accident, then that would be an issue. You cannot refer to it. So this is only applicable when you are working in an organization that collects data about past accident. And there are also complex methods, especially in the high-risk industry, whereby you can apply certain technique, such as listed there. There's HAZOP, Hazard and Operability Study. There are also fault tree analysis, failure mode and effect analysis, bow tie analysis. So these are special made techniques by the industry to a tool that can be used to discover the hazard that relates to a certain job or a certain process. You can just type the terms there and do a YouTube search, and you can find a lot of information on what is HAZOP is all about, fault tree analysis, failure mode. But for the scope of this course, it's just enough for you to know that technique exists. You don't have to go deep into understanding this technique, except for bow tie. Bow tie analysis is part of your quest later on. And if you are dealing with chemicals, one of the most important reference that you need to look at is what is called as safety data sheet. Yeah. So all chemicals should come with safety data sheet. Safety data sheet is basically like a leaflet that comes together with the substance, the chemical, that tells the user about the property of the chemical, what is the hazard of the chemical, what is the safety precaution, how to store it, how to use it, and a lot more information that give the user of the chemical awareness and more information on how to use the chemical properly and safely. Yeah. So safety data sheet is very important. If you are an industrial hygiene technician, for example, holding that character. So one of the most important things that you need to find when you look at a chemical is to find their safety data sheet. In some companies, they don't keep this safety data sheet. Usually they buy chemical and they don't care whether the safety data sheet is provided or is supplied together with the chemical, and they just use it. There is no information apart from labeling. Sometimes label also don't have. So it's just, a plain bottle of white liquid that we really don't know what's inside it, except for the one that just bought it. So information about substances is very important because we need to know what we are using. A lot of chemicals just look like plain water, clear, like plain water. If it's within a bottle that has no label about what's the content of the bottle, it can be very dangerous because anyone can just take that bottle and maybe drink it, assuming that it is plain water. Instead it is, very dangerous acid. So, in order for you to identify the hazards of substances and chemicals, you always go for safety data sheet and also the label that is pasted on the container of the chemical, whether it's a bottle, a plastic wrapper, or a box, or whatever it is. It must have, by law, they must provide with some kind of information that relates to the hazard of the chemical. Yes, within this Wakelet page also, I include a introduction to what is a hazard, so you can watch later on. So in your quest tree, then you should apply all of these method. Okay, it can be a single method, it can be a combination of methods. That is up to you lah, what is appropriate, so that you can identify the most significant hazard that relates to your character. So use that method and identify what are the hazards. And later on, we will talk about the detail of the hazards. But in your case, it would be preferable that you read something about it beforehand. You have to do your own search and your own research or to related to the hazards that you have chosen. So when we have already identified the hazard, okay, the next process would be a risk assessment. That one something that we will learn about it later. Okay, and I have a different Wakelet page for risk assessment, so we will talk about risk assessment later. But for the preliminary stage, for the early stage, at least you need to know what is the consequences. What can the hazard do? In order to identify whether a hazard is significant or not, you need to know what kind of damage that it can do. What is the level of harm that it can do? So, if a hazard can contribute to fatality or death, then that is considered as significant. But if a hazard, can just the worst case scenario is just a small cut to your finger, and that is not considered as a significant hazard. So significant hazard always go for the worst, things that relates to death, things that relates to what we call as terminal illness or terminal disease, a disease or illness that cannot be cured, something that relates to you losing your parts of your body permanently, becoming blind, becoming deaf, or you're losing your important body parts, like your legs or your hand. If you lose your head, of course you will die lah. And losing capability, becoming paralyzed. Although you still keep your limbs, parts of your body, but you cannot use it. Becoming paralyzed, that is also significant. Severe poisoning that can cause you to get serious disease like cancer, or what we call as debilitating disease, the disease that that paralyze you, that makes you cannot work. That disabling disease that makes you just just lying on beds. That considered as significant, that makes you become vegetables. cannot do anything else, so that is significant, or is capable to cause a big destruction. For example, fire, like destroy the whole building. If it's a chemical, it can spread and kill a lot of people. If it's can pollute, or can damage a lot of things. So those are the things that is considered significant. So the next step will be to identify what is the risk, the likelihood of that happening, but that is in different weeks lah. So when we already identify the existence of a hazard, we need to control it. And especially those hazards that is considered as significant. So how do we control hazards? Because hazard management is basically the heart of OSH, the heart of occupational safety and health, is being able to identify hazards and control hazards. So when we think about how to control hazard, we always refer to what we call as the hierarchy of control. The hierarchy of control. So the hierarchy of control consists of 5 steps. 5 steps. So you can see in the display right now on the screen. So whenever possible, always go for elimination. If you see a hazard, always go for the elimination. If you see a mosquito and you are afraid that mosquito can carry disease like dengue, so the most easiest thing for you to do is to smack the mosquito, kill it. That is elimination, and then you are safe. If you see a snake, if you brave enough to kill it, go and kill it. When the snake is dead, then the hazard is no longer there lah. Being bitten by the snake. So elimination is the most effective way of controlling hazard. That is to eliminate lah. Make it gone. If you can. But in most cases within the industry, it is not so much possible to eliminate all hazard. Usually in a small percentage only that we can eliminate the hazard. But like chemicals, processes, the machineries, usually it's there. It's difficult to eliminate. If you cannot eliminate, then go to the next step. Substitute. Substitute means to say replace the source of the hazard. If it's mechanical, for example, you are using machine, maybe change, sell the old machine that is dangerous and buy a new, safer machine. If you are using a very dangerous chemical, throw it away and use a safer chemical. If you are using a dangerous process, redesign it, change it into a safer process. That is what it means by substitution. So replace the high level hazard to a lower level hazard. There might still be hazard, but it's less significant than the earlier one, than before this. If you cannot eliminate and you cannot substitute, then go to the next step, would be for engineering controls. So elimination, substitution and engineering control is considered effective methods. So what is engineering control? Is basically you put in some kind of engineering design, that does not rely on human. The keyword here is engineering control does not rely too much on human. So it runs by itself. For example, sensors. Okay, sensors runs by itself. For example, isolation, guarding. Okay, if there is a dangerous parts of a machinery, so you put a guard and you cover it, so it will be there. Yeah? It will not move around by itself. It will not go for tea at night, for example. It will stay there unless somebody move it lah. But it is there. It is reliable. So engineering controls is a reliable method. Okay. There's a lot of engineering control in place. For example, isolation is part of engineering control. Ventilation is part of engineering control. Physical guarding is part of engineering controls. Putting in sensors, putting in detectors are engineering controls. The fire sprinklers, that detects fire early and then let water comes out to extinguish the fire, that is engineering control. So we don't have to rely on human. So these are reliable hazard control method. And try as much as possible to have engineering controls. Do not too much rely on administrative control and PPE, because administrative control and PPE depend on human. Okay, we rely on human. So try as much as possible to use a combination of engineering controls, admin control, and PPE. So the best method for controlling hazard that cannot be eliminated is to have these three together. Yeah? Engineering control, admin control, and PPE. Don't use it in isolation. Yeah? So try to have all three together to control the hazard. So admin control is something that is considered as, rules. You prescribe rules or procedure, SOP. Like right now we have COVID-19 situation, and we just say to the people out there, okay, follow SOP, follow SOP. Is it reliable? I don't think so, because it depends on the people to follow SOP. If they want to follow, maybe one day they follow, another day they don't follow. Vaccination is kind of elimination. They try to create an antibody within ourselves, so that whenever COVID-19 virus enters, and it automatically kills that COVID-19 virus. So that is vaccination is considered as elimination. But asking people to follow SOP is an administrative control. Asking people to fill in checklists is admin control. Relying on people doing inspection, that is admin control. Relying on people meeting together, because as we have learned before this, people can have error. People cannot be perfect. They might forget, they might sleep about something, they might forget about something, they might make a mistake, so it's not a very reliable one. So you cannot use admin control as a single control method. Go for training is also admin control. So when you see a hazard, when you see the high COVID-19 case is rising in Sarawak, and you say, okay, send everyone to training. So that is not a proper way to do it lah. So, and ask people to follow SOP, put the temperature detector. Okay lah, temperature detector is half engineering control, but it depends on the people to put their forehead to the temperature. It cannot detect from far away. If there is a temperature device, then that can detect automatically the the temperature of somebody whenever they are within a certain place or a certain space. That would be good. But now our temperature depends on people to put their forehead. Sometimes people put their hands to the temperature. Sometimes they just skip the temperature. temperature detector. So so using our COVID-19 situation right now, a lot of it is using administrative control, which is unreliable, and we can still see cases, the first wave, the second wave, the third wave, and the fourth wave. So admin control. And the last resort would be PPE. Also, this is the last. If you cannot do elimination, cannot do substitution, cannot do engineering control, cannot do admin control for some reason, then the only thing that you can do that is PPE, giving the people who are working with dangerous jobs some kind of protection. So PPE is considered as last resort because it doesn't protect much. It can only protect, a certain hazard lah, not all. And it depends on the human too to prepare to wear the PPE properly. You can use the COVID-19 situation also right now to see the effect of PPE. So part of the SOP is for people to wear face masks. Okay. But there are variation of face masks. A lot of people don't wear face masks. If they wear face masks, it is of low quality, or it is something that is fashionable but it's not protective. And when they wear it, they don't wear it properly. Sometimes it's revealing the nostril. So if you reveal your nostril, then there's no point of wearing face mask. The face mask should cover your breathing zone, your nostrils and your mouth. So there's a lot of, and then people start arguing about the effectiveness of, different types of face masks, and people complaining about face mask is not so comfortable, feel, hot or uncomfortable. It hurts your ears. So a lot of complaint. So PPE is the last resort, but you can, that is part of the package to protect you from COVID-19 is to wear face mask properly. So you can use the hierarchy of control in our situation right now. The best way to, to be free of COVID-19 is to kill COVID-19, in whatever ways we can. So vaccination is one way, but vaccine is still not effervescent. To say it's not very effective yet. Maybe it takes a couple of years down the line to make sure that the vaccine is really effective. There are cases whereby people are still being affected by COVID-19 even though they have been vaccinated by 2 doses. So if you are substitution, well, currently we cannot substitute the virus lah, but you can substitute people. If you have to go somewhere, if you are afraid to catch COVID-19, you can send somebody else. So let them get the COVID-19, not you. That is the concept of substitution. Okay, engineering control is to have a good ventilation to suck out the air that might be infected by COVID-19 virus elsewhere. Okay, so good ventilation is also a part of good control of COVID-19. So if things that you can put inside your room that can suck out air, then it can be very effective. But it's gonna be expensive. So engineering control, usually people don't like it because it's expensive and time consuming and very technical. Admin control, I've told you before this, SOP and all, and PPE is the face mask. So there is a YouTube video on the hierarchy of controls. If you still cannot understand what I'm talking about these past minutes. Okay, this is another illustration of the concept of hierarchy of control. Okay, so the elimination, the substitution is focusing on the hazard, not the people that you want to protect. Don't eliminate the people. So if you choose to eliminate, focus on the hazard. If you choose to substitute, focus on the hazard. If you choose engineering control, it can be on the hazard, or it can be the space where the hazard can travel to meet the people. And if it's admin and PPE, it's more on the people. We don't put PPE on the hazard. We put PPE on the people. We enforce SOP is not for the hazard. Hazard don't understand SOP. The people that have to follow SOP. Okay, let's look some of the hazard category and what are the items within that category. So in general, hazard can be classified into 5 categories. Okay, number 1 would be the physical hazards. Number 2 would be the chemical hazards. Number 3 is the biological hazards. Number 4 is the biomechanical hazards. And number 5 is the psychosocial hazard. So what are the items within the physical hazards? The hazards that is considered as physical hazards are listed as radiation. Either it's an ionizing or non-ionizing radiation. Ionizing is relating to radioactive material. Non-ionizing is the wave, gelombang, like electrical wave, telecommunication wave. There are also noise hazards, temperature extremes of object, of the surrounding ambient temperature, or the temperature of certain surfaces, like your ironing, the iron, it can be very hot. Mechanical movement or action, machinery hazards, gravity related hazards, free fall, slip, trip, drop, collapse, overturn objects, electrical hazards that relates to shock or electrocution or arc flash or explosion. It relates to stored energy, consists of hydraulic, pneumatic or kinetic nature. Sharp, pointy or protruding objects or edges, like your kitchen knife. And nanomaterials also is considered as potential hazards also, but it's not something that is an issue right now, because nanomaterials is something that is rarely used only in certain industry. It is not rigorously researched, and it depends on the situation, but it is considered can be a hazardous nanomaterials. So chemical hazards are those properties that is considered as hazardous, like corrosive, flammable, or toxic, or can cause cancer. And there are also other type of substances that is categorized under chemical hazards, such as dust. So dust explosion in some of the team's selection, dust is considered as chemical hazard. Fibers, such as asbestos fibers, and certain particles that are coming out from a chemical process, like fume or vapor, also considered as chemical hazards. And if you are looking at chemical hazards, you need to be familiarized with the symbols. Generally the GHS. It's a symbol that is used internationally right now, and that indicates the hazards of chemicals. Biological hazards consist of bioorganism like viruses, parasites, bacteria, fungi, and toxins coming from certain plants or insects. If you are dealing with like bees or wasps or snakes and all the animals that can sting you and paralyze you from the toxin that they produce, that is toxin, because they carry toxin. So the venom is a toxin, neurotoxin, venom. It's not exactly the snake that is dangerous, it's the toxin within their fangs, the neurotoxin. Biomechanical hazards, usually popularly is known as ergonomic hazards, such as forceful exertions. You're using extra strength to do a job, repetitive motion like typing with the keyboard for a long period of hours, awkward body posture where you have to twist your body to the left, to the right, or to bend for a significant time that can cause your back to hurt, sitting or standing too long, okay, or other environmental factors that can affect our ability or comfort in doing the job, such as the lighting, the vibrations. These are considered as mechanical hazards. And lastly, the psychosocial hazards. It's a mismatch of work condition and workers' mental process that leads to stress. Okay, stress is considered as psychosocial hazards, violence, aggression, fatigue, and bullying. So these are some of the popular hazards that you can find in industries or in the world of work. Okay.